This is lesson 123. You guys, look at how far in the book we've gotten. This is pages 598 to 600. We're going to cover square roots of numbers greater than 100, and I'm going to introduce you to functions, which is fun. Okay, so our first example is the square root of 400. Now remember what square root means. We're looking for a number that is multiplied by itself that will equal 400. Okay, your book promotes a guess and check method. I don't like that method. I don't think that that's a good way to go about this. You could be at it for a long time. What I want you to do instead is think about the factors of 400, okay? Now remember our factor trees. A lot of you guys were getting confused with adding and multiplying, but remember, remember our factor trees, right? Now, remember too that you should memorize these perfect squares from 0 to 100. You should have those memorized. They're your simple math facts. So you should know that 8 times 8, which is 64, so the square root of 64 is a perfect square. That's going to help you out a lot right now. So if I look at 400, what times what equals 400? That's going to be my square root of 400. All right, I'm trying to write neat, but it's like my finger doing it. So, all right, this is the same as saying the square root, you should see the 4, right, in 400, times the square root of 100. It's exactly the same thing. It equals the square root of 400. Well, what is the square root of 4? Okay, it's 2. 2 times 2 equals 4. And what is the square root of 100? What times what times itself equals 100? 10. Okay, so the square root of 400 is 20. This is not a guess and check method. It is a logical way of going about and a mathematical way of going about this. Okay, can you tell I'm kind of annoyed by that? Anyway, so now our next number is the square root of 625. Again, I'm going to use the factors of 625 to figure this out. First of all, I know that this is not divisible by 2, okay, because the last number is 5. I know it's not divisible by 3, because if I add all these numbers up, I don't get something that's divisible by 3. I get 13, and 3 does not go into 13. So if I'm thinking about my perfect squares, 0 to 100, I have 4, which is 2 times 2, 9, 16, 25, and then my next one is 36. All right, I can rule out a lot of these because it's not divisible by 2 and it's not divisible by 3. So it can't be divisible by any of these, but it might be divisible by 25. So let's see. 25. All right, so 25 goes into 62 2 times because I make 2 quarters make 50 cents. And then 125 is 5 times. Okay, well look at that. It's 25 times 25. So the square root of 625 is 25. Okay, because 25 squared equals 625. All right. That's the end of those examples. Our next one is functions. So I'm going to copy the chart on page 599. So Nathan thought of a rule that would use the length of the side of a square to find the perimeter S. Okay, Nathan's breaking new ground here. Just kidding. So the perimeter, of course, would be all the way around. And what he found was that when you have side S, if you multiply side S times 4, you get P, right? So if I multiply 5 times 4, I get 20. 7 times 4 is 28. 10 times 4 is 40. So if we use this equation, 4 times s equals p, then what is the perimeter for a side 15? Well, it would have to be 60, right? Okay. That one is an easy one. Well, maybe not. I don't like saying things are easy. Anyway, so now I'm going to copy the next function table, see if you can find a rule for this. So we have L and M. And when L is 5, M is 20. This is kind of like when you were younger and they were using patterns and they said, which one comes next in the pattern? And you had to figure it out. So we don't know what happens when you put 7 in. What do you get when you have M? That's our question mark. If L is 10, M is 25. If L is 15, M is 30. So when L is 5, M is 20, we might think, oh, okay, you just multiply by 4 again. But if you look down here, that's not the case, right? Because if I take 10 and I multiply it by 4, I get 25. I don't get 40. So we have to come up with a new rule that would fit all of these numbers. Okay? So I'm going to give you a second to look at it. 5, you do something to 5, you get 20. You do the same thing to 10 and you get 25. And you do the same thing to 15 and you get 30. Well, you should see that all of these are an addition of 15. All right? So to get our unknown M, all we need to do is add 15 to L. So in this case, it would be 22. Now, you can come up with an equation just like we had 4s equals p, M equals L plus 15. So whatever L is, all we have to do is add 15 and we'll get M. This is all a function is. So let's move to the next example, copy the table. And in this function, you have when x is a number, to get the other number, you have to multiply it by 3 and subtract 2. So it's giving you the function. So for instance, when x is 2,